Hello. Okay, so we're continuing from where we were a second ago. I'm back. We left everything in a broken state. We were in the middle of trying to figure out how to rebuild everything to use tensors, pretty much. I think I had just figured out one of the issues and was not able to fix it yet. So let's just run Python main.py. The issue was that I'm expanding the number of expanding the number of dimensions while doing the training pass to take into account the batch dimension, and then in the non-training pass I have a vector that's got one fewer dimensions, and these gammas have too many dimensions, and it causes this to broadcast, which gives us something that's way too high dimensional. So I don't want to actually modify the dimensions. I just want to temporarily expand them, and then we'll just have to do that on each loop, on each iteration of the forward pass. Then here we don't care about self.gamma anymore. We don't care about self.beta. And now hopefully that fixes our issue. I tried to research whether this would create a copy or not, and my research was inconclusive, so we'll just have to see. So I just tried to make this thing have 65 dimensions. Where is this? Line 91, right here. Of course, because I forgot to remove that one self dot. Okay. Line 109. So D is 64 by 50 because it's a whole batch. Gamma is just by 1. So I think here I can say reshape D.shape. No, I can't do D.shape. I just have to add dimensions. I have to do this crap again. I don't actually need beta. And gamma is used only right here. Self gamma equals gamma. While you don't have enough dimensions, add more. Obviously, I meant to say gamma equals self.gamma. Okay, new issue, line 54, 53, I mean. Too many subscripts for operand 1. Yeah, because I'm describing matrix multiplication. But x is a vector. So why don't we just add how do I do this would be a different while len of x dot shape is less than len of self dot weights, then you give x more dimensions. I hate doing this. There has to be a better way. I think PyTorch has something called squeeze and unsqueeze, which lets you add these 1 dimensions easily. But I don't think NumPy has unsqueeze. Too many subscripts in einsum. Didn't I fix that by adding the extra dimension for x? Print self.weights.shape x.shape. Too many subscripts in einsum. Oh, I added way too many extra dimensions to x. Why did it keep doing it? Shouldn't it have stopped after the first one, when this len of x dot shape len of x dot shape, and x should be getting bigger and bigger as we're going through the while loop. So it should no longer be less than 2. What's going on here? Why does this keep... I don't understand. Print me the len of this and the len of this. it's 2 and then a number that... Oh, yeah. Okay, I printed them in the wrong order, but weights stays 2 and the shape keeps getting bigger. So why do we keep going into this while loop? That makes no sense to me. Does that make any sense? Why does that... Here, print them in the right order and then also print the loop condition. Oh, because I didn't do dot shape. That would explain it. Okay. All right, we're making progress. These all look good. 64, 1. So I'm printing. Let's remove the prints that we don't need. So we don't need this anymore. That might be the only one. Clear. Run again. And then we're printing. What's going on here? Oh. No, it's not possibly unbound anymore. Weird. Expected shape is a number. Actual shape is a one-dimensional vector. I wonder if it's a one-dimensional vector with just one value. Actual, yeah, just print actual. Yeah, I think that's this 53. So this argmax ended up being a number, and this argmax ended up being a vector with just a single number in it. I'm not sure why they would be different. What if I print x.shape, y.shape, self.apply x.shape. Just print a high first so I can find it among all my print statements. Where's my high? Here. So X is my input, and that's 10 characters, so 87 times 10, 87 possible characters times 10 locations. Y is my output, which I expect to just be a single vector. Or Y is my expected output, and then the next thing is my actual output. So I think here's where I get to squeeze. to remove the extra dimensions that are just 1. Stuff is happening. There's too much printing for me to see anything. So let's clear all that. Let's get rid of all of our print statements all over. Those ones are allowed. This one's not allowed, not allowed, not allowed, not allowed. I saw learning. I think 10%, 10%. That's not a lot of learning. That's not any learning. Wait, 11%? Maybe that's okay, actually. Hello. I'm still printing stuff somewhere. Where's all my print statements? Ooh. So let's comment that out for now. Actually, let's comment out all the profiling stuff for a second. Wait, where am I printing these weights.shape? Here. Get rid of that. Kill this. Learn a tiny bit real fast. Only 50. Okay, it learned it. It just outputted nothing but new lines. All right, hard to see if it's working, but we could train it with, what's going on here? Layer norm, linear, ReLU, skip, and softmax cannot be assigned to parameter list layer. One of those things doesn't count as a layer anymore. I wonder how I broke that. I mean, this is annoying. I hope. I would like to fix this. Which one is it? If I remove softmax, if I remove everything except layer norm, what is this? It doesn't take an empty list. It doesn't update. Okay, it's all right with layer norm. It's all right with linear. It's okay with ReLU. It's okay with skip. And it's okay with softmax. Okay, I don't know. If I delete this again, okay, it just seems to work. I don't know what the issue is. And then I'm missing this. Okay, and then batch size 50. Let's use more than 100 training examples. Let's go back to 10K. Which was good enough to have perceptible learning. 23%, 30%. We're back to normal. Okay, we're back to how it was before I broke everything. Kill that, say hello. Oh, but it's still not outputting. This might be a new problem, actually. Okay, I think this is just an issue with the code down here for decoding the output or something like that. This looks wrong. Print weights.shape. Okay, say hello. Weights.shape is 87.1. And then I'm trying to take the last dimension, which doesn't make sense. Weights dot, and that's as far away from how you spell squeeze as it can be. Can I just squeeze at the end here? So the reason I'm squeezing is so that this while loop will only grab a dimension that... This is not the right way to do it. Let's kill this. But this should say stuff now. Okay, it's probably saying stuff, but I am printing in between. Clear. This is not the right way to do it, because what I want to do is this. I want to select the last dimension. Hello. Look at that. That looks like dialogue. So let's kill that. Try this again. It should still work, because it shouldn't enter the while loop. Okay. Now, let's break it again by trying to use tensors as inputs. So let's go back down to 100 just so it's fast. And see. Does this do anything? Okay, we've got an error. Operands could not be broadcast together with shapes 870.11, which is what gamma is, and 87.10.50. Oh, I need different input dimensions if I'm going to be doing it like in using the tensor inputs. So mnist input, vectorized text, and this one is tensorized text. You don't do times cars. Why is ReLU under... Oh, because I'm actually missing a comma. This would be for mnist output. This would be for text output. Okay, new error. Cannot reshape array of size 278,000 into shape 6487. Okay, let's figure out print param dot shape, print layer param dot shape. And then my moments need to be the right shape also. Param.shape, grad.shape, m1.shape, m2.shape. Let's print all the shapes. So the layer is linear. Param.shape is 64 by 87 by 50. It's not supposed to have a 50. If this is a weight layer, it's not supposed to have a 50. I should print name. So and then let's see if the grad has the 50, then we screwed up the backwards pass. So weights is the issue. Param has a 50. Grad has a 50. Wait. Param does not have a 50, which is correct. It shouldn't have a 50. Grad has a 50, which is wrong. And then M1 and M2 have the 50, which they just got because grad has the 50. So how can grad and param differ? Because param gets set by the shape of the grad. Does it not? No, the param starts correct. So the param starts correct. No, wait, okay. This is what I'm forgetting. The grad does have a 50. Does it? Or... You have a bunch of different gradients from a bunch of different examples in your batch, and then you're supposed to sum them. Are you not? I guess we weren't summing them back when the... What am I trying to say? Linear. We weren't summing the batch dimension before. Why not? We are summing the bias dimension. Why wouldn't we sum the batch dimension? Or sorry, we were summing the biases along the batch dimension. But we were not summing the weights along the batch dimension. But not summing the weights along the batch dimension now means you end up with a 3-dimensional output. The weights are 2-dimensional. That's very confusing to think about. I guess I don't get why we weren't doing it before. The gradient of the weights is the gradient of the output matrix multiplied by the activations of the input. So back when we were doing just 2 dimensions, well, let's start with vector. Back when it's a vector, then this would be an outer product, which would make a matrix. When it's a matrix with a batch, I would be the feature axis. J would be the, well, it's a little confusing because I'm also transposing A and T here. First thing is the feature axis, second thing is the batch axis. But now, first thing is the feature axis, second thing is the sequence axis. And the batch is not coming into it. I think I need to do an extra sum. Along the batch axis. Axis equals It's just confusing to me that I'm treating the batch axis differently from the sequence axis here. So what did this break? This broke. I need to come back to do. Why am I treating the sequence axis differently from the batch axis? Okay. What's my new issue now? Learning schedule update. My validation is not a number. What is it now? Just print the percentage. What is it actually? Oh, it's not a float. That makes sense. It's a different answer for each token. But what am I using this for? Because I need to get a number at the end of it. So let's, do we take the average? I guess we sum it at the end here. So what am I trying to say here? This is we've got two vectors. How do I end up with a matrix here? Shouldn't the argmax give me a vector at the end? All this dimension stuff is so confusing. Print expected.shape actual.shape. And why am I casting this to an array? I wonder if I was trying to do something and then I forgot and I didn't finish this. Yeah. This was supposed to be array equals equal. But then I changed my mind and I said, actually, I should do it for each token. And then take a sum. All right, just what am I working with here? Expected is a vector with 10 values. Actual is 10 vectors with 64 values. So one for each token. Why is there a 64 there? There shouldn't be a 64. I think I am trying to, I meant to squeeze before taking the argmax. Shouldn't matter because the first axis is not the one that's getting squeezed though. Print me the actual expected. What are we looking at? Shouldn't expected be 10 characters? Okay, so these are the encoded. Encoded's not the right word, but, or actually it is the right word. These are the encoded values, and my actuals, I'm like not taking the argmax properly or something. Print apply x.shape, which is going to be 3D. Oh. I'm summing along axis 0, but what I mean to do is sum along every other axis, I think. Or no, I don't want to sum along every axis. I only want to sum along the axis that has 87 in it. What's 64? And what's 10? So shouldn't it be 87, 10, 1? Okay. I don't understand the shape of my output. So we go back to network. We go to forward, or even apply, and we print all of these. Or let's do forward. No, let's do apply. Let's do apply. Print x.shape, and then print it again after each layer, and then print it again at the end. And print input between them. Why am I doing array equal now? I thought I got rid of that. Anyway. Something's not working. because I'm not supposed to have a 64 by 64 by 10 activation at any time. It should be 64 by 10 by batch size. So it should be 64, 10, 50. Is this a difference between apply and backpropagation? So if I go to backprop and I print XS, oh, I didn't mean to print XS. Print x.shape for x in XS. In excess. $87, $10, $50, $87, $10, $50. All the way through it's working properly. It's only when I go to a different dimension input that it gets screwed up. Okay. And I think it's the change that I just made to linear that's doing that. No, but it should be in the forward pass though, actually. So how about in the forward pass you print x.shape self., or let's do self.weights.shape x.shape self.biases.shape. And it should work properly for most of them and then not work properly for the ones at the end of the after apply input. So let's just make sure. Back when it was dealing with tensors, weights is a matrix. X is a matrix with 10 tokens and 50 examples. Biases is just a column vector the whole time. Okay, and then once we're doing our other forward passes, our biases are too big and that's screwing everything up. And I should have known that because this is the exact same problem as before. So biases equals self.biases add a bunch of dimensions. I mean, is that even necessary, or import numpy as np np.array 1 2 3 b is this, x is np.array 1 2 3 1, 2, 3, 4, 5, 6. B or x plus b. X dot shape, b dot shape. It looks like it should just be able to broadcast it. So why do I have to do any of this? Can't I just remove that? Remove that. Expand X if I need to, but let bias be, yeah, don't add the 1. So now it doesn't think it can broadcast. But what about the example I just did? NumPy, X and B, X dot shape, B dot shape, X plus B. It broadcasts that, but if X had more dimensions, it wouldn't. X dot reshape 3, 3, 1. X dot shape. Why is it saying 1, 1, 3? What the? Oh. Okay, 3, 3, 1. X plus B. X dot shape is 3, 3, 1. B dot shape is 3, nothing. So why can it broadcast that, but it can't broadcast this 64, 10, 50 and 64, nothing? Am I allowed to do that? No. X equals numpy dot ones 64, 10, 50. X dot shape 64, 10, 50. B equals numpy dot ones 64. X plus B. Huh. I don't understand the broadcasting rules. It seems like sometimes it does and sometimes it doesn't, and I don't know what the rule is. What if it were just 6410? It doesn't allow that either. But isn't that exactly what I was doing before? So I'm doing this. I don't understand. Like, why does it, what are, yeah, this is what I'm doing. Trailing dimensions are compatible. Well, it says this should work, but it's not working. I don't get it, but I know that this will fix it. Because I need to do this. Well, and I need to do, no, that one's fine. Wait, what did I just change? Yeah, because I need to do that. And then I don't know why I'm doing array equal. I don't actually want to do that. I guess, but I don't know what I do want to do. So let's print stuff and then figure it out. Where's my printed stuff? Where, what? Why did this stuff not print? Am I stupid? It's all the way up here. Okay, this makes sense. Now this is saying I have 10 examples. Well, no, not quite, because I meant to argmax. I did argmax, so now I have 10 examples. And these should just be numbers. I should just compare the two numbers. So okay. I want to get rid of all my other print statements. And then here I have 10 examples. So if I sum them, I check how many of them were right. I sum that, and now every example is 10 examples. So in order to get a percentage, I need to divide by 10 here. What's the other way to say that? It would be y len of expected. Okay. That looks like we learned something. That's okay. Let's not get ahead of ourselves. First, I want to go back and make sure that I'm still working the old way. I think there's a chance I broke it with the sum of the length of the thing at the end. Yeah, length of expected. Because expected is just an integer sometimes. Or not an integer. What's the right way to say sum the second dimension of y, whether or not there is one? Samples per sample. That's such a weird way to say that. Labels per sample equals 1 if len of y dot shape is greater than 1. Labels per sample equals, instead of labels, can I call it examples? That's already what sample means. Let's go back to labels. Equals y dot shape of 1. I don't have a y. Give the first validation data. Times labels per sample. So now this should be 1. First example, and then 1 is the label. I'm ending up with huge percentages, so I'm not doing this properly. Print labels per sample. And right now I'm doing the vectorized one. 1, 1, 1, 1, 1. So 1 is right. Print expected and actual. Expected is just a number. Actual is a list of ones. Oh my god, why can I not get this right? What is... Is it the squeeze? I don't think I should need the squeeze anymore. Why am I ending up with so many? Expected dot shape, actual dot shape. And this is probably going to throw an error because expected is a number and does not have a shape. No. Okay. 64. So 64 is not supposed to be in the output at all. Print x.shape. self.apply x dot shape. Um, 870, that makes sense. And then the output is 87 by 64, but it should not be. It should not be. It should not have a 64. So we just keep managing to screw up our dimensions. Okay. So let's go to backprop, print x.shape for x in xs, and then exit. I'm guessing that it works properly during the backprop. Yes, we don't end up with a 64 in the output. And now the apply. X.shape. And then you can just exit after the first one. We're picking up a 64 by 64 in the first linear layer again. I don't know how many times we're going to fix this. Print self.weights.shape, x.shape, biases.shape, and exit. We've already got an exit, I think. Yeah. Um, 64, 870, 871, and biases is 64, nothing. Why is X 871? And why did biases not get expanded? Oh, I think it's literally just the order. First grow X to shape, then grow biases to X. That looks right now. Okay. So expected dot shape is nothing by nothing. Actual dot shape is 1 by nothing. So expected is just a number. Actual is a number inside a thing. I wonder if that is fixed by squeezing. Because why should they have different shapes if x and y have the same shape? Okay, that does fix it. Okay. Clear this, run this. Oh, labels per sample. So I'm saying I got to 10%. Yeah, looks about right. Clear this. Let's try doing 10K. Which should still be fast. $23, $28, that's what we're used to seeing. $32, and that looks like dialogue. Kill this. And now for the test of tests. Tensor inputs. I'm doing 10,000 examples, which will be, I was gonna say it should be 10 times slower. It looks like it's faster than that. Maybe we're getting benefits from batching, like maybe doing this many at a time is still pretty fast. And it's getting like surprisingly high, 25%, considering that it can't it's basically only able to look at one character. Okay. So if I did not have softmax, or if I increase the temperature, I guess I would expect that very soon it would get stuck in a loop of outputting the same character infinitely. Because my understanding is it's only able to see one character. It looks at one character and needs to make a prediction out of that. Yes, this is also possible. Because this is a loop. It's not the kind that I was expecting. Yeah, that's the kind I was expecting. Okay. All right, so I think we have done the impossible. Tensors, check. train on every token, check. So I guess I want to do attention next because I can't really make more progress where tensors are the inputs. Or the other thing we could do is do some of this other stuff, the encoding stuff, before switching over to tensors. Now let's do attention. Attention. I don't know what I want. Yeah, this is what I'm looking for. I just want to see attention as a network instead of as a formula. Okay, we'll just do this. We don't have, I mean, do we have scale? Decoder only, does that matter? Where's that Stack Overflow post I keep using? So this doesn't show the scale. I think you... Actually, I don't know if you need the scale because the softmax already scales. We can try it without the scale first, I guess. Anyway. So we need a way to split the input into 3. And then we have linear, and then we have matmul. So what's this going to look like? It's going to be like multi linear, linear, linear. I'm trying to figure out the right way to write this in code. How am I going to say matmul? Because that needs to consume the last 2. Okay, I guess I can think of it like this is one big linear layer. No, not quite. I was going to say this is one big linear layer and the input is itself concatenated with itself 3 times, but these should not know about each other. So it's not a big linear layer. So what's a good way to write this? I don't know. I'm having a brain, like a blank. I can't immediately think of a way to do this for some reason. This is not, by far not the hardest thing we've had to do. So like I could make a layer called attention that has a forwards and a backwards. Maybe that's the right way to do it. But then does that even help me? So I would say attention 64, let's say. But then what does attention look like? It's like class attention. So you would say like QKV equals x dot copy, x dot copy, x dot copy. And then you pass each of these through a linear. The init that we said we take is a is an int, yes. Size int. So we make 3 linear layers. Self.l1.forward of x.copy. KV L2 L3. One of these is allowed to just be naked X. Then you would do matmul. Which I have not defined yet, but we know the dimension. So this is going to be, and then you also need a softmax. Does softmax take a size? I don't think it does. No. So then you would just say L1 dot, or M, the attention matrix, I guess, is equal to self dot softmax of self, or here, let's do it step by step. M is self dot softmax. Step by step, I said. Self dot matmul1 of forward. Actually, matmul has no learned parameters. So we only need to do that. Class matmul is basically an activation function. Def forward it's a weird forward because it takes an X and a Y. It's not literally this. I'll have to use einsum. Well, why not just do it then? np.einsum ij jk goes to ik of x and y. One of them needs to be transposed. Let's not do the transpose yet. Let's add it to when we need it. And then does activation function? No, it does not define a backwards. So what's the backwards for this? It's like, oh, not that, not that, this. It's like, I don't know actually. Let's put a to-do on that. So there's only one matmul. QK. You matmul, you softmax, you matmul again. And then don't ask me how to do the backwards pass. There's a lot of parameters to learn. Which means I want to use this block thing so that I can take its save and load and get attribute. So for that I need layers. How am I getting the name? The name is a hash. Okay, so it should be fine. So here, this is weird, but I need to pass these to the parent so that they can be saved and loaded and the weights can be grabbed from them. Okay. I don't need to save the matmuls and the softmaxes though, because they have no learned parameters and I can just re-init them from nothing here. Now block, yeah, this should be fine. This should be fine. No, there is a problem. Load needs to, when I load, I need to set the L1, L2, L3s also. So I have to override load. So I can just do layer equals super dot load, turn layer dot L1 equals layer dot layers of 0, 2, 3. Okay. so now I have to implement matmul and backwards in order to get a single attention head. So I'm pretty sure that okay, this is kind of weird because I need two deltas. And the rest of my framework is not ready for two deltas. Because it's going to be like delta 1, delta 2. This is how you got forwards. To go backwards is like the same thing but backwards. So it's like one of them is ik to ij. The other one is ik to jk. But the thing that's going to take this gradient is not going to know what to do with this. What's going to take the gradient? I suppose each of these linears is going to take the gradient. It's going to, I mean, something in here is going to do it. So this is going to be the gradient coming from here. We're going to have to split it. It's going to be like delta 1, delta 2 equals self dot matmul dot backward of DNA. Okay. Grads equals this. Grads of delta 1, grads of delta 2. This is not the right A, actually. Because this is the input from that comes into attention. So I have some steps, there's some intermediate steps to save. Matmul. But I'm taking A, which makes no sense, because I don't have a single input activation. I do have a single output activation, but I'm not sure how to do this actually. Matmul backwards PyTorch. There's a blog post, this one, that so X is the first matrix, A is the second matrix, Y is the matrix output. Okay, here's the summary. So X and A are the two inputs. So this is delta, this is D, this matrix is D, derivative of L with respect to the output. It's just that I have two inputs, so I don't have A like this. Or not here, but here. So why don't I just do self.cache equals xy, and then on the backwards pass, grab it from the cache, I can treat this as a regular matrix multiplication, so bring back this. You are delta matrix multiplied with Y transpose. You are X transpose matrix multiply with delta. Okay, so that's how you do the matrix multiplication. Ooh, but that's why I need two matmuls, because they need separate caches. So this A does not matter. I'll just say whatever, you don't get one. Matmul 1. Okay. So now I have this gradient and this gradient. Why don't I call this delta 3? It's confusing, but otherwise this will be 1, 3, 2. So now we softmax self.softmax.backward delta 1. Softmax. Does it really need the... No, it should just use S here. That should be fine. So I don't think we need A. I kind of want to drop the idea that anything takes A. I just want to say you just take the gradient, because this is kind of annoying to keep track of. If you need A, you just cache it. Self.cache equals X. Don't take A. Now, I was using A just to get a shape of something. Can I use D for that shape? What am I? I'm a layer norm. So I don't think my shape changes. I don't think I changed the shape, so I think I should be able to use D for this. Backward. Don't take A. What am I here? Linear. I do change the shape. So I do care about A. It's just that A equals self.cache. I can just remember it. Self.cache equals X. Let's just call it X. Why call it A? So my crusade against A means you're not there. Backward. You don't need to exist. I can already see that you don't need to exist, and you don't need to pass it backwards either. D, D. Don't need A. We weren't even using it. Okay, then we need to change network to not pass that in. I think that's the only place, yeah. because I've done a lot of crap, let's just see that everything's still working. I'm still trying to pass two things into backwards here. Actually, that simplifies things because I don't need to remember X. So I don't need to cache the inputs. And I don't need to zip the cache. Nice simplification. Hopefully it works. Yeah, looks like it's working. Let me guess, TTT, close enough. Close that. Just because that's not super convincing, let's make sure it works with something that where it clearly is typing English. We'll give it 3 epochs. 25%, 30%, 32%. Hello. I guess that wasn't a lot of time to learn much, but that looks like it's working. Okay. Back to the tensors. Back to attention. Let's import attention. So we go backwards through the softmax. We go backwards through the first matmul, so this should be matmul 2. And you don't need to pass in a second argument. So delta 1 and 3 is going to come from these grads, and these grads are going to come from matmul 1. What's D here? This would be delta 1. Then these all go backwards through their respective linears. So delta 1 equals self.L1 dot backward of delta 1. Two, 3. Now I have 3 deltas. But I've only got 1 delta to return. I think I just sum them. think that they each contribute equally to the gradient. Yeah, you do, because that's what we did with the skip layers, is you just summed them. Okay. I mean, did I just implement attention? And did we just become best friends? So I've only got one attention head, so it's not like attention. Yeah, I only have one attention head, but the way you would do it is the input comes in, it immediately goes through attention. I want to do this. So you are the vectorized input. You are the tensor input. We'll forget about MNIST input for a minute. Now we'll put MNIST down here. MNIST input. Okay, so MNIST input looks like this. And then let's just have a single layer followed by a softmax. Linear softmax. No layer norm. Not 64, but 10. So that's how you do MNIST. I'll comment this out. Tensor input, so we don't need to worry about these. Let's get rid of this skip layers. It just goes input, attention, I'm just going to do a linear in between. Linear, attention, add a norm, which means you get a skip. How does skip work? It takes a list. So you put attention right here. Does the norm come before or after? I can never remember. Transformer architecture. Show me one where the adds are explicit. Where's the one from Wikipedia? This one. So this one says norm first. So layer norm. Attention. Oh, the skip comes from before the layer norm. So norm, attention, skip. And then it goes norm, This is going to be in a skip as well. Norm feed forward. So that just means linear ReLU linear. And then you add, and then you have a norm on the outside and a linear to get the outputs and a softmax. So this is the tensor input. And then let's get rid of the comments for these. So let's try them one by one. Vectorized input, do you work? Vectorized input. I think that's in attention, but I shouldn't have attention on this network. Looks like you work 23, 30. You say some stuff. Clear. Let's comment you out. Try mnist. Mnist Shyamalan. Yes, I'm not loading the right data for that. Comment you. And then I need this temporarily. Amazing, amazing. Look at that growth. Yeah, after 5 seconds, we're at 91%. So cool. So fast. Okay, let's go back to, now let's try tensors. So this is the moment of truth. We already found the first bug, so we'll just fix that, which is that attention, these should be size, comma, size, all of them. Crossing my fingers as hard as I can. Line 233 in layers forward. Matmul. Operands could not be broadcast together with remapped shapes. 64, 10, 50. 64 new axis 50, 10. 64, 10, 50. 10, 50, 64. Oh, okay. That's really hard to read, but I think I just need the transpose that I mentioned earlier. So which one do you transpose? they both, the first axis for both of them is the feature. Therefore something. Therefore what? It's like, it's 87 by something. Well, I'll just think of it as 80. I know it's 64, but just to make it make sense to me. Well, whatever, let's do 64. So it's 64 by 10 by 50. They're both 64 by 10 by 50, and I want the output to be also 64 by 10 by 50. So that means I want to transpose the second one. I want this one to be 10, 64, 50. And doing a y dot t is the same as doing kj, but I'm just going to do yt because I find that easier to understand, even though I know it's equivalent. I still am not that used to reading the einsums. Okay. These dimensions are getting all messed up. ij, jk goes to ik. That's how you do matrix multiplication, I think. Why are we trying to add a new axis? I don't understand. So isn't this what I'm doing in the linear block? ij, jk goes to ik. Weights times x. Though in this case, I'm not transposing. So I don't think I should have to transpose now that I'm looking at it. By putting the J here, I would think that, oh, actually, but these matrices are probably compatible and these ones aren't. And transposing is not exactly what I want to do either. So what if I just do kj just to make it explicit about which axes are being transposed? That might solve it. (64, 64, 50). Why is it 64, 64, 50? Man, I have so much trouble with these einsums. Because if I just if I replace these with B, is this right? And if it is, then why is it different? Does this even make sense? Is this how you do it? No. All right, robot chinwag, save me. Einsum is all you need. Matrix vector multiplication. Ik, comma k goes to I. Matrix matrix multiplication. Ik, kj goes to ij. Ik, kj. And I have just renamed k and j here, so his k's are my j's and vice versa. I, j, jk goes to ik. So this is matrix multiplication. But I think I need the ellipses to say, yeah, to just say like plus the rest of them. Plus the batch dimension, I mean. Batch matrix multiplication. IJK, IKL goes to IJL. ijk ikl goes to ijl. And then, well, his indices, or his batch dimension might not be the same as mine. IJL. I just don't know which index. I'm guessing I for him is the batch because it's not changing. JK, IK goes to IJ. So if I put the I's at the end, there's only so many permutations of 3 letters that you can do, and I'm just not even through trial and error, I'm not finding the one that I mean. Yeah, I'm just so far away from what I'm trying to do for some reason. Three, 2, 5, 3, 5, 3. So 3 must be the batch dimension. And this is 2, 5 by 5, 3. So why would putting the I's at the end not... Oh, okay. I have to put the I's at the end because my batch comes at the end. And I have to flip my K and my L so that the Y is transposed. Or in other words, I can just do that. Why would that not work? At least it has the right batch dimension in the end. So what if I call it IB? JI. IJKL. He has 4 letters. So it's like IJB. KIB. And then IKB. Hold on. I'm close. I'm close. IJ, JK, IK. But I had this at some point before, I thought, and with the ellipses instead of the B. Oh, you can't do the transpose. Don't do the transpose. Just flip J and K. The transpose was putting the 50 at the front, so I don't know what it was doing, but it wasn't transposing the axes that I care about. How is it? Why does it start with 64, 64, 50? I mean, this kind of looks right. It's basically what I'm doing here. IJ dot 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 JK but transposed dot dot dot. Don't do the transposing because that's gonna be transposing the wrong axes. How am I ending up with 64, 64? X dot shape. It's not 64. It is 64. The second matmul is 64. Okay. Maybe the mistake is not where I thought it was. Maybe this is working fine. The issue is just, why does the second matmul have a different shape? So forward, it's supposed to be doing... The first matmul has the right shape, and then we're soft maxing. And then it's the first input that has the wrong shape. The first input being... Oh, no, you know what? That is right. It should be 64 by 64. Because I think this is supposed to be a matrix. And then this matmul is kind of like a matrix on a vector. It's a different kind of matmul. Because there's a transpose that happens only on K. Maybe it would be... Because I don't want to transpose this one, because then I end up with the wrong shape. So maybe I should do my transposing outside of the matmul. And the matmul should just do ij, jk, and then on the way back, jk, jk. No, these need to be transposed. Right? This should be transposed. This one is supposed to be transposed, so this one's supposed to be ji. Then K should be transposed. Equals numpy.einsum ij goes to ji, and the rest can stay the same. Which means I have to transpose the gradients out of this matmul. So delta 2 should be transposed. Insanity. It's too complicated. If this works, I can't expect this to work. Like, okay. Where's the problem? So I get that this matrix is what am I trying to say? This matrix is 64. So it's like, this is a 64 by 64. I'm getting really confused now with the size of the tensors. Because each of these is like a matrix already, even though sometimes I'm talking about them like they're vectors. What's the formula for attention? K transpose, which I'm doing. Q matrix multiplied by K transpose, and then I'm not doing the scaling, though I should. To do scale, which would come before the softmax. So according to this, it should be working. I shouldn't need to do anything else to make sure the dimensions are correct. Q times K. So let me write it down. Q is going to be 64 by 10 by 50. KT is going to be 10 by 64 by 50. Q matmul KT is going to be 64 by 64 by 50. It just is. So that part makes sense so far. Then we want to multiply this by V. And what are U going to be? So V is the same as Q. So that's going to be 64 by 64 by 50. So the output of the attention is a different size. Something's not making sense here because I'm at the end of this, I'm supposed to have one prediction per token. M by D, N by D. Why are these different dimensions, Q and K? Why is Q different than K and V? Maybe that's just the general case, but with self-attention. Causal masking. I'm still not sure if this makes sense, or if we need this or not. Does the scale matter for the backwards? If you multiply by a constant, does that change your derivative? Yeah, it does. Derivative of Cx is going to be C. So I think if I do the scaling, which I can do, it's just M divided by equal square root of size. Square root of self.size. I'm not saving size yet, but I can. I guess I'm implicitly saving it as the size of the layer. So if I, whatever, self.size equals size, and then when you load self.size equals L1. dot shape of 0. L1 dot weights dot shape of 0. So in the forward pass, if I divide by square root of self.size, then in the backwards pass, this is on delta 1 before it splits. Delta 1 before it splits. Because it's this value. Okay, I think that's right, but I'm doing so much stuff that I don't know how to tell if I'm right. The matrix dimensions, that's my current problem that I got distracted from. I thought that, okay, so it's saying in the end, I'm going to get something that's m by d. And m is what? D is my 64. So I'm guessing m must be my 10. And I'm supposed to get something that's got a 10 and a 64, but my 10 got eaten in the first thing here. So K transpose is D and then N. So this should be M by N, which means it should be 10 by 10. That actually makes sense to me. It should be 10 by 10 because attention is supposed to have a matrix that has a value for each pair of words or tokens or whatever. So it should be 10 by 10. It shouldn't be 64 by 64. Okay, let's figure that out. (64, 10, 50). K transpose is 10, 64, 50. So it seems like what I actually want is to transpose Q So let's do an alternate world. Q transposed would be 64, 10, 50. Q Q transpose times K would be equal to, wait, this would be 1064. So this would be 10 by 10. And then you multiply this by V, but I'm guessing I have to transpose this also. Well, it won't matter because it's symmetrical. I might have to transpose this. Because this is going to be 10 by ten. But I want 64 by 10. So I think what I want is V transposed multiplied by this. A lot of stuff is ending up backwards because of my choice of indices. So V transposed no, don't transpose V. Keep V the way it is. That's going to end up being 64, 10, 50. Yeah, that's what I want. This is Q transposed K. Okay. Q transpose. Then we do, so delete this. Q transpose K. Scale. Softmax. V attention matrix. Then on the way back, I need my drawing, my picture, my queen. On the way back, so Q is the one getting transposed. On the way back, but also the order of these is different because it's V. Whatever. Let's just. Actually, that matters. So on the way back, I've got delta 1 and delta 2 that correspond to this grad and this grad. So delta 1, so I want to call this delta 3 and this delta 1. This is like flipped for me. Then delta 1 goes through the softmax, gets unscaled or gets rescaled. It seems wrong to multiply by this instead of divide by it. It seems wrong that I'm doing the same thing in both directions. I don't know if I'm supposed to be multiplying here. I actually don't know. What's the backward of the scale? Then we go back through the this matmul. For me, Q is the first thing, K is the second thing. Q is the first, K is the second. So that's the same as this, so this order is the same. And then delta 1 is the one that needs to untranspose, because 1 is the one that I transposed. And then we go back through our linears. Okay. So where are we failing right now? It is line 239 in backwards. From matmul 2, so undoing the first one backwards is failing. Okay. This is supposed to just be the inverse. So the way forward is ij, jk goes to ik. I don't know why I had a bunch of weird stuff here. So this is the way forward. The way backward is, that's what we were looking at here. So, oh, but this is going to be messed up because our indices are backwards, isn't it? But this looks normal, ij, jk, ik. And then the way backwards is also a matrix multiplication, delta y transpose, x transpose delta. So if this doesn't work, we just need to swap these indices, but that's what we did a second ago and it didn't work. But in theory, we have the right thing up to like some transposes. So why don't you print me d.shape, x.shape, y.shape, and then exit. Um, 64, 10, 50. 64, 10, 50. That makes sense. This all makes sense. So I want to do some kind of matrix multiplication with d and y. So 64, 10, 50, 10, 10, 50. To get back a delta 1 that should look like, I believe it should look like 10, 10, y for delta 1. Because that's the shape of the input activation. So that's going to be tough because I can't get rid of the 64 because I only have one 64. I have to make something with a 64 and a 10. Maybe I'm wrong about the shape that's needed. Well, there's only one choice for delta 1, I think, which is 64, 10, 10, 10. Which means the only choice I have is transpose the... I could transpose nothing and do d times y. And then for delta 2, so that would be using these two, d and x. I have two choices. I have to transpose one of them. Okay, that's a new error. I should have a to-do here. To-do should it be there's only one other thing it could be, so I'm just going to write it as a comment. Which is these matrices are the same size, so either that or I could have done kj. Wait, is that even true what I'm saying? Yeah, I think it is. So what's the issue here? Delta 1 is a dictionary. And I'm trying to multiply it like it's a something. Delta 1's not supposed to be a dictionary. Oh, I have to grab delta out of this. And then have to grab delta out of these also. Oops. And I don't have to do it elsewhere. Line 238. IJ, JK, DY. Oh, this is the one that I thought that this was the only way to do it. Print x.shape, y.shape, d.shape. So the first one worked, and then the next one didn't. 10, 64, 64, 10. And the delta is 10, 10. There, okay. So out of D and Y, so out of these two, how do I end up with well, this is the thing. I only have one choice, and it's to do not this. It would be to do KJ. Or possibly put the Y in front and do exactly this. So I'm guessing that D would have to be in front for this one. I don't know what the second one should be yet. Let's just get an error and then fix it. Did I fix the first one? No, I broke it even earlier now. These are not the same definition of matmul is not working out well for me for both matmuls. So 64, 10, 50, 10, 10, 50, 64, 10, 50. And this is matmul 2, which means delta 1 is which one was delta 1 again? I think for me, delta 1 was, well, it just depends what's the first argument. So to the second matmul, the first argument is v. So for me, delta 1 is 6410. So out of these, how do you get 6410? There's only one way. And it's to do y times d, ij, jk, ik. I mean, this is already, it looks right to me. I guess I could do a transpose. I don't know. I don't think I should. So this delta 1 looks like it should be working. And where's the error? ij, jk, ik. It thinks that wants to go (1010) to 6410. That's true, it does. I think that just means I need dy. Line 240. So now my delta, my second one's not working, and I'm guessing this needs to be xd over here. Nope, that still doesn't work. This thinks it wants to do 6410, 6410 to 1050, 64. I don't know how we lost the batch axis. But let's figure it out. So x is 6410. D is also 6410. So we do need to transpose. And I don't know which one we should transpose. So we'll try this. And that got past the first matmul backwards pass, but not the second. So in the second, I mean, it got past the second, but not the first. So in the first, you've got 1064, 6410. Wait, did we transpose the second argument? No, we transposed the first argument, 1064. And now it doesn't like delta 1. So for this, for these two, and I want to get to 6410, you would need to put y in the first position. Why am I ending up, I'm just changing the same thing back and forth because each one needs it a different way for some reason. But they're both supposed to just be a straightforward matrix multiplication. Yeah, y has to come first for this one. But then for this one, we want it to be 10 by 10. So y doesn't have to come first for that one. So let's make y come first because it has to here. And then for this, does it work? It would be, here I'd end up with 10 by 10. Here I'd end up with 64 by 10. No. I wouldn't end up with 10 by 10 here. Here D needs to come first. Oh, I'm losing my mind. I need to do something with these to get 10 by 10 back. There isn't actually a way to do that, though. Because 64 needs to be on one of the ends. What am I doing wrong? I'm doing something very wrong. X, Y, D. So the gradient coming from up here is 64 by 10. I want the gradient going to V1 to be 64 by 10. And the gradient going to Q and K to be 10 by 10. So I want this, which is the gradient going to V1, to be 6410. So that would mean doing this would work, dy. And it's the only thing that would work. The only other thing that could work is dy transpose, which probably is what you're supposed to do. kj. Then the gradient going to here, which I'm calling delta 2, right? Because I'm putting v as the first argument. Yeah. So the gradient going here, which is delta 2, is supposed to be 10 by 10. So you take this, and you get something 10 by 10, which means you do this times this. It means you transpose this x, so you get 10 by 64, and then you multiply it by that. So like this, exactly the way I have it written. And that's what should work on the final matmul layer. And if I reasoned it right, it should also work on this, because why should they be different? Oh my God, I finally had a thought that made sense. And it's actually outputting something. Okay. I'm so happy. Okay. Where's all my print statements? Right here. Don't need you anymore. So what am I actually doing right now? I'm doing a single-headed attention, one layer decoder only transformer. And it's learning. Because I haven't done positional encoding, it doesn't know the difference between the letters. That basically, when you go through the first attention block, the matrix that it's doing, it like knows the relationships between the letters, but it doesn't know which letter is which, what order the letters are in. So this can give an idea for it can predict the next token, but not based on the order of the letters, which kind of means I would expect it to predict the same next token for all of the inner tokens as well. No, not necessarily, because those would have different sets of letters. So it's learning, but it's learning something really weird. It's learning, like, if I have this set of letters, what should the next letter be? Which could help it to some extent. Like it could learn to memorize the input and do well on the training data. That's not going to generalize very well, probably, though we're up to 40%, which is pretty interesting. So after 2 minutes of training, what does it look like? Hello, yeah, so capital letter C and a lowercase l means you need an O, you need a U, you need a D. So it learned something, but without the positional encoding, it's not learning anything that helpful. But that's sick. We implemented attention. So let's go back to our goals because we're killing it. Attention is not totally done. We got matmul. We don't have concat and multi yet, which should be simple, and this is what's going to give you multi-headed attention. But we should be able to do that because that's not the hard part. Because what's that going to look like? It's going to be like, where do I have attention? Here. It's going to look something like multi. And then I want to say how many heads. Heads equals 6. I don't know what how many heads do people usually use? How many heads in multi-headed attention? 8 to 100. I mean, it's going to be a lot. It will really increase the number of parameters in the network when we add these because of all the linear layers inside. Each one of these is 3 linear layers. But yeah, so what does multi-headed attention look like? It looks like you split your input and then you concatenate and add a linear. So that should be doable. Let's add, where are we? Attention, let's add multi. Multi. Which def init. It's got layers, so we do need to remember the layers. It doesn't have layers, it has layer. But we can treat it like each of these is a block. So like that. So remember your layers. Remember heads. Then I suppose we need to, do we need to save and load the number of heads? Yes. Ooh, actually, they need different weights, so we can't do it like this. You know what I mean? Because this initializes the weights in the attention block, but we need to initialize them separately. Okay. Multi-headed. I want to make it kind of general, even though I'm never going to use it for anything else. So this should work. So it won't look like this anymore. Now it's going to be four layers equals. You don't take layers, you take a class of type layer. Class size for blank in range heads. Oh, and size. I don't know if I need to remember the number of heads. I do have self layers if I need to. So that's init. Well, actually, there's a few more layers we need. We need a linear and a concatenate. Linear size. No. The first one is heads times size. Self dot linear equals this. Self dot concat equals concat, which doesn't exist, but we'll implement it. Concat. I think this is a block also. Okay, this is going to make sense soon. Layers.append self.linear and concat so that the saving and loading will work. I need to do this thing to make sure that I can load them as linear and concat. Let's just make them 1 and 2. No, let's keep them like this. forward. You do the blocks in parallel. So for layer in self dot layers, but don't count the last two. You activations equals that, activations dot append layer dot forward x dot copy so that gets you all the activations. Then you concatenate them. Self.concat I don't know that concat needs to be its own. Well, it'll be helpful. Self.concat.forward. Each of the heads, each of the activations. So does this work? Can you do that? I'm not doing that. I'm doing concat's not a block. It's more like a is it more like an activation function? It doesn't really care what kind of inputs it has. Concat x's. How does that work? NumPy concat. Concatenate. Okay, and then what axis am I concatenating on? I don't even know what axis I'm concatenating on. Is it the feature batch or the sequence? It should not be the feature or the token. Oh, I don't know. What's the one that's 64 big? That would be the feature. So I guess I am concatenating along axis 0. Um, so I have a bunch of deltas. I have a delta for each thing, for each input. So maybe for this one, I'll return a list. I don't have anything learnable. I don't want to do this in a different... I'm going to do it a different way than everything else. This will just be a list. And it's basically unconcatenating. NumPy unconcatenate. Undo concatenate. Split. AB, C is concatenated of AB. You do split. Specify the indices where the split should occur. So that would just be np.split d, comma, indices. Did I just import something? And then my indices are going to be, like, I can cache x.shape, which is all I really need. Shape equals self.cache. The shape along the first axis is the only one I care about. That's just called size. And then I just want to, this just needs to be like I times size for I in range d dot shape of 0. Now I don't know if I'm supposed to skip the first one. From Python, import numpy as np, a equals np dot array 1 2 3 4 5, a dot split np dot split a 0 2 4. The first one ended up being empty, so I do want to skip the first one. put a 1 here. Why did I end up with 3 arrays? Oh, because I put 2 splits. So let's say A is 1, 2, 3, 4, 5, 6. And now I'm splitting, and let's do it properly. I times 2 for I in range 1, 2, 2. Or 6. Wait, I'm ending up with a bunch of extras. Oh. Divided by size. Perfect. So that's forward and backward. Okay. So indices equals this. Does that convert stuff to a list? NumPy or Python import NumPy as np np.array 1, 2, 3 list of np.array 1, 2, 3. But does np.split return an array or a what does it return? It returns a list. Okay, it already returns a list. So forward is do all the activations in parallel. I even want to write this in a functional way. Activations equals for layer in self.layers. I wish this were in 2 lines though. Can I add a, I can't force it. And then you concatenate them and you just return that. No. that gives you your x, and then you have to pass that through a linear. Return self.linear x dot forward x. Okay, then def backward. So d equals self.linear.backward d. In the end, we have to return delta. So undo the linear, undo the concatenate. Delta equals self.concat dot backward d. This is a list of deltas now. Deltas. Just call that d. Then each one of these goes back through its respective head. So deltas equals self dot, or just layer dot backward of deltas of I for I just call this delta for I in range for delta layer in zip of self.layers self. Or just deltas self.layers. Now let me just check zip of 1, 2, 3, 4, comma 1, 2. It stops after the first one, so we won't go through the linear and the concat, so this will work. And then in the end, we sum our deltas together. Axis. It's every axis. Am I allowed to, is that what that means? NumPy sum along every axis. No, it's not every axis. What am I talking about? It's, but deltas is a list. So this is just a Python sum. But NumPy sum should work. So NumPy.sum of np.array 1, 2, 3 comma 1, 2, 3 But yeah, this is just a Python sum. Let's try both. np dot array 1 2 3 1 2 3. Yep, that's what I want. And np.sum is not what I want. I did want the Python sum. Interesting. Okay. Is that it? Main. Do I have two heads now? Concat. I don't need to tell it how many heads it has. It can figure that out, interestingly. Line 300. Yeah, I want like the first X. And let's call this X's. Line 305. D is a dictionary, but it's not supposed to be a dictionary, so I must have forgotten to grab delta out of this. And this as well. Something's happening. It seems like it's okay. I was gonna say it's a lot slower than it's slower than 2 times slower, which should be the most amount slower that it should be. But I don't actually know that. It seems like it's 14 point something seconds per iteration, and before it was around 7 seconds. I wouldn't have expected that attention takes up. Oh, well, attention, I guess, does take up most of the parameters. It does seem like we're learning faster, because after 2 minutes, we were around 40% before. I don't know, maybe we're learning about the same. 40% after 1.5. About the same speed, but maybe the point of the multiple heads is not to learn faster, it's to make better use of the parameters in the limit, I mean. Okay, has it been 2 minutes? About 2 minutes. Let's kill it. Say hello. Hello, 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 hello. Can we figure out the cloud trick again? Clo-lo-lo-lo-lo-lo. We managed to get cloud colon. Yeah, we're missing the oops, didn't mean to close that. We're missing the positional information, which is going to make it not very good. But guess what? Concat done. Multi done. Multi-headed attention is done. So here's where we are. Oops. We're almost done, actually. Because once we do these things, there's nothing left to do except scale up the training data and run it for a long time. I guess there's stuff we could do for efficiency, so we can make this work on GPUs. But scale like crazy. That's it. That's our whole checklist left before we have made an LLM from scratch. So I'm finally going to end it here. Thank you for watching. I hope this was helpful.